And now finally we're going to look at exponential functions and equations. Equations involving exponentials and equations involving logarithms too. If we're not going to be able to work with these functions very well if we don't know how to solve equations involving them. Throughout the semester we've solved linear equations, quadratic equations, equations with radicals in them, equations with fractions in them, and now finally we get to exponents and logarithms, and that rounds out the whole gamut of equation solving in intermediate algebra. This is it for the semester. It's good stuff. I'm going to do this in a couple of videos. One that's going to deal with the two quick properties, and then the next video will deal with the tougher types of problems, what you have to do with them, okay? The quick properties we're talking about are, for example, right here, it says a to the m equals a to the n. If that's the case, then it has to be that the powers m and n equal each other. Okay, and the reason for that is if you look at the graph, it's because of the one-to-oneness of the function itself. So let's say that this, for instance, is y is equal to a to the x. And someone says, hey, guess what? I found out that these two guys are equal. If a to the m equals a to the n, whatever value that is, a to the m equals a to the n. Well, when I skedaddle back to the curve and drop down to the x-axis, it has to be that m is equal to n for that to happen, because the curve does not swing down and give you another opportunity to be equal to those guys, okay? So that's not happening because it's one-to-one. If this is equal, then you must have started with the same input. And you can argue that with an input guy as well. A to the x here, and you plug in m, you plug in n, they go to the same place, a to the m or a to the n. Well, these guys have to be equal to each other. Therefore, these have to be equal because it's a one-to-one function. Okay. Anyway, we use that, and it's also true for logarithms. If log base a of m equals log base a of n, again, they're equal to each other. Okay? So let's watch this in action. These are the first types of problems that you study. Quick property for exponentials and a quick property for the logarithms as well. The exponentials don't start off too obvious, do they? It's like 3 to the 2x is equal to 27. What the heck? What do I do? Well, if we're going to take advantage of a to the m equals a to the n implies m equals n, then we have to get, this is the thing, we have to get the same base on both sides of the equation. Okay, so we're going to take 3 to the 2x is equal to 27, and we're going to see and take a look at both sides, and eventually, hopefully, we recognize, you know what? 27 is 3 cubed. It is. It is? It is. Because 3 times 3 equals 9 times 3 again is 27. I'm supposed to know that? Yes. So you can explore it on your calculator. What you want to do is take this equation and write it as 3 to the 2x is 3 to the 3. Why? Because then we can use this property. If you have the same bases and you have an equivalent statement, then the powers, 2x and 3, must be equal. See how that happens? They drop down, you set the powers equal to each other, and easily solve for x after that. And the answer is 3/2. Watch. If you check it, 3 to the 2x equals 27, and you decide to check and take 3/2 and put it there, you're going to get 3 to the 2 times 3/2 power is 27, so cancel. 3 cubed is 27, and indeed it is. So the answer is 3/2. We're solving for variables in a power. That's pretty good stuff. Try this one. I recommend you write it in the following form. 2 to something equals 2 to something else. Then I think we might have one more. Yeah, we do. Try it. They're all done this way. You want to make the bases the same so that you can set the powers equal. Okay. So you paused it, assuming we paused it, right? Okay. So what I see is, I see 8. 8 is 2 cubed. And then it's taken to the 3x plus 1 power. On the other side, I see 1 over 2 squared. Another name for that is 2 to the negative 2. Okay, so we're looking at 2 cubed to the 3x plus 1 is equal 2 to the negative 2. We're almost there, but now we have to go back to our power rules from section 1.5. What do you do with those power to a power? You add them. No, you don't. You multiply them. It's 2 to the 3 times 3x plus 1 is equal to 2 to the negative 2. Are we good now? Do we have the same base, different powers? No, the powers have to be the same. If these guys are equal to each other, then the powers have to be the same. So we have an equation. We drop down from above, and we have this. You see how that happened? We had to transmogrify, if you will, both sides to have the same base. Now, this only happens for specialized problems. If this is difficult for you, in the next video, I'll show you a way to do it with logarithms that it works for all problems, okay? But, you know, if you happen to see it, this is faster and you get a pure answer. We just solve this from here on out. We go 9x plus 3. You've done this before, right? So 9x is negative 5, so x is negative 5 over 4. And by the way, over 9. By the way, you don't have to check your work. It's going to be true. If you did the math right, you're going to have an answer. It's not like other problems where you had to check to see and all that stuff. Logarithms, when you do logarithms, we do have to worry about those guys because you can't plug a number in that causes log of a 0 or log of a negative because, well, I didn't say much about this. I drew the graph, but the logarithms can only take positive numbers. Okay, so we do have to worry about those guys, but not these. Last one, have at it. What do you think there? Let's see. Oh, I know. 64 is 4 times 4 is 16 times 4 again is your 64. So on the left, it is 4 cubed to the x power. On the right is 4 to the 4. This is easier than the last one. That's nice. 4 to the 3x is 4 to the 4x plus 1. Therefore, drop it down. Same base, right? Same base. Therefore, the powers are equal. I do this on the board sometimes. 3x is equal to 4x plus 1. Therefore, negative x is equal to 1, so therefore x is negative 1. That's all she wrote. That's how that's done. So those are the so-called, not easier, but they're doesn't require a calculator and grind work. You just go, if I can make the powers match, if I can make the bases, let's write that down. If I can make the bases match, number 1, make the bases or bases match. 2, equate the powers and solve, and that's all we're doing. That's it. Okay. The trouble with it is remembering, and then secondly, how do I make the powers the same, and do I remember my power rules? There's a lot of ifs there. Okay, it takes a little bit of practice. Teachers always go, oh, they're going to remember their power rules. They've got to remember those power rules, and people forget them. Okay, so be careful. Okay, we're going to end this video with these problems. I think there's only 2 of them. It's the quick property for logarithms. Very quick property. And that one says, if I have log base A of somebody, and it's equal to log base same base of somebody else, then those 2 somebodies are equal. And that's all there is to it. Okay? So here I have log. What's the base, by the way, if I just write log? Well, you have the natural base, which is ln of x, which is base e. Then you have the common base, which is log, which is what? Base 10. So we're looking, if they don't put a little 2 or a 5 or whatever, then it's base 10. But in these problems, well, in some other problems, it does make a difference. In these problems with the quick type of story, we're going to be okay. Watch. Okay, so we have log of r plus 2 equals log of 3r minus 1. Therefore, the argument is, if the logs are the same, then the stuff inside are equal. So we simply go, boom, r plus 2 is 3r minus 1. You're kidding. No, I'm not. And we solve. Bring this over as a negative r. Bring that over as a positive 1. Looks like r is 3/2. That's done. Oh, that's easy. Let me do the next one. Aha, watch out. The next one has 3 logarithms. What do? Egad. Well, this I put into the mix because you're going to see this too. Do you remember the story about logarithms in the previous section where you can use properties of log? Yeah. This is property number 1. Do we have to do that? Yeah, we're going to be able to combine the log on the 2 logs on the left to get 1 logarithm, and then we're going to be able to solve it. Okay. So we have to use the property, and what we would write is, well, it's going to be log of 2x plus 1 times 4 is equal to log of 7x plus 8. Now, to be sure you see this, I'll use brackets. All of that is inside the logarithm. Okay. When you combine it together, it goes inside as the argument of 1 logarithm. Therefore, we can use the property. It says the powers, the arguments, they call them arguments, the argument inside the logarithm, they have to be equal if the logs are equal and have the same base, okay? So what we have is log equals log implies stuff equals stuff. To borrow from one of my colleagues, stuff equals stuff. And the stuff is this stuff equals that stuff. So we're going to write 2x plus 1 quantity times 4 is equal to 7x plus 8. And you solve. Okay, I'm going to distribute, right? Now we're out of the log world. We're just into chapter 2 and equations solved, right? So 8x plus 4, 7x plus 8. Looks like what we're getting. Subtract the 7x is x. Subtract the 4 is 4. Answer is 4. Okay, the answer is 4. And that's it for this video, though. That's part 1, where you equate the bases or you equate the logarithms together. The logarithm story won't change much. You're going to have to use properties of logarithms to manipulate, but then you'll see. We'll see it in the next video. All right, see you there.